Hello everyone, good morning. Number 22 of order and differential. This class you started method of variation of parameters. The last video for method of parameters, and still we have three more topics that are left are orthogonal trajectories, solving higher order, solving higher degree differential equation, and Laplace transform solve a differential. Right? So these are the three topics. In this class, we will completing this topic of variation. Yes, the previous class we have solved 10 problems based on method of variation of parameters. So we will just recall what is by method of variation of parameters. So it's clear, right? Hello. Hello. What is clear, right? Is it low? See, the voice is breaking, right? The voice is breaking. It's okay. So we'll start. I think the voice is breaking a bit. Okay, so okay, so we'll start. If my voice is breaking means I will redo again. Okay, so we'll start. If my voice is breaking means I will redo again. Just a minute. Okay, so I'll start. I think my audible now. So in the previous class, we have started method of variation of parameters. So there we have started part one. Right? So in the previous class, we have solved 10 problems. Start with 11th problem. So we will just recall what is meant by method of variation of parameters. Okay. So what is the working rule for solving d square by dx square plus p square by dx plus qy is equal to r? Remember, the coefficient of d square by dx is p1, right? Rewrite the given equation as y2 plus py1 plus qy is equal to r. So first you need to put r is equal to 0, right? So if you put r is equal to 0, you find the characteristic function that will be u plus c to be in that format. You take u and v from here. After the identified particular integral, so u into f of x plus p into g of x. This is the formula for pi. So I have given the formula for f of x and g of x, right? F of x is minus integration of dr by w. G of x is integration of ur by w. Find f of x and g of x. R is the RHS. Make sure that the coefficient of d square by dx square is less than is equal to 1, right? So after that, you need to find what is W here. So you know U and V. U and V are from characteristic function. R is the R is in the question, and W is the rod skin of U and V. This is what is in the previous class. So we have solved almost 10 problems in the previous class. Okay? Previous class, you have started 10th problem using method of variational parameters. All d square by dx square minus 2dy by dx plus y is equal to x e power x sin x. X power x sin x. With y of 0 is equal to 0 and dy by dx at x is equal to 0 is 0. This is what we have stopped at previous class. Okay? So we'll continue with the 11th problem. So just recall, right? So the general solution is cf plus pi. Pi is u f of x plus b g of x, and the u and v we obtained r is equal to 0 and finding characteristic. Right? Start with 11th problem, right? What's audible, right? So solve by method of variation of parameters, right? So we will do fast, right? Maximum I'll do another 6 to 7 problems or 5 to 6 problems, and then wind off stuff, right? One problem. Solve square y2 plus x by 1 by 1 y is equal to e power x by method of variation of parameters. Okay, actually, this is a Cauchy-Euler equation, right? Of variation of parameters. You can also do the same problem by Cauchy-Euler. What you will do in Cauchy-Euler? What you will put x is equal to e power z, z is equal to log x. This will be transformed to d1 into d1 minus 1. This is transformed to d1, and you have to replace this d by d plus 1 in finding particular integral. This is what you do when you are solving by Cauchy-Euler equation, right? Now we're going to do the same problem, the method of variation of parameters, right? Take the same problem, you do by your own, right? That is, you apply Cauchy-Euler method to solve this equation. You get the same answer one. But now we are going to solve by variation of parameters, right? You can do the same problem by Cauchy-Euler method because it's a Cauchy-Euler equation, right? In finding pi, you need to put d is equal to d plus 1, and you need to find, you will have x square, so you need to apply polynomial in x type 3. So we'll solve this, right? But our very first step is step 1. So first you need to put r is equal to 0, right? R is 0. So we have here y2 plus xy1 minus y is equal to 0. We want to solve this equation in finding the characteristic function, right? So how you solve this equation? Cauchy-Euler equation. To put x is equal to e power z, like that will be log x, right? So you have to replace this x square d square by d1 into d1 minus 1, and we have to replace xd by d1, right? The equation is same as square d square plus x minus 1 of y is equal to 0, right? So what is d1 here? d1 is d by dz, and here d is d by dx, right? Now we have d1 into d1 minus 1 plus d1 plus 1 of y is equal to 0, right? So you have to replace x square d square by d1 minus 1 xd by d1, right? Solve the equation. We have d1 square minus d1 plus d1 minus 1 of y is equal to 0. These two will get cancelled. We have d1 square minus 1 of y is equal to 0. The roots are plus or minus 1, right? Roots are 1 and minus 1. Therefore, it has distinct real roots, right? It has distinct roots. Therefore, the characteristic function will be e1 e power z plus c2 e power minus z. Remember, very important. Here, the independent variable is z, right? In that case, you need to put e power z plus c2 power minus. The previous gen problem, we have this to be a constant coefficient, but in this class, we solve all these by variable coefficient. This is your characteristic function. After that, you have to log x. Same as c1 e power log x to x power minus, right? So characteristic function. So u of x is x and v of x is x power minus 1 or 1 by x, right? And make sure that x is not equal to 0. This is for u of x and v of x. Now, what is r of x here? Very, very important now. What is r of x? R of x is x square by e power x divided by x square. In finding r of x, this term has to be 1. That is, the coefficient of y2 has to be 1, right? But here we have x square. That means we have to divide entire equation by x square. Therefore, your e power x will be your rx. Very, very, very important. In all previous 10 problem, you can see the coefficient of y2 is always equal to 1 for all the previous problem, right? But here, so I'll just show you the previous, right? You can see, rewrite the given equation as y2 y1 plus y is equal to r. That means the coefficient of y2 has to be 1. So in this here, you can see in all 10 problem we have solved, the coefficient of y2 is 1. You have directly taken r to be secant n x, right? Here you can see your r is cosecant ax because your coefficient of y2 is 1. All the problem you can see, first 10 problems, coefficient of y2 is 1, right? But here we have x square here. That means you divide by x square. Therefore, your r will be x square e power x by power x, right? That is formed by rewriting the equation as y2 plus xy1 by x square minus y by x square equal to x e power x by x square e power x by x. Right? Therefore, r is e power. Very, very important thing. Whenever you have variable coefficient, make sure while taking r, you need to divide by this coefficient of y2. Now it is very simple. Right? So what is your partial integral? U into f of x plus v into g of x. We already know u and v. So u is x, v is x power minus 1. What is f of x? F of x is minus integration of r by w dx. So that you find Wronskian, right? We will find w. What is w? Wronskian of u and v. So u dash u dash v dash, right? u dash v dash. So your u is x, derivative is 1, v is 1 by x, derivative is minus 1 by x square. So cross multiply, you will have minus x by x square minus 1 by x, right? Minus x by x square minus 1 by x. What we will do is we will multiply x. Therefore, we will have minus 2x by x square minus 2 by x, right? Minus 2 by x is your Wronskian. Minus 2 by x is your Wronskian, right? Or will be integration of b. b is x power minus 1, r is e power x. Very important, right? You should not take r to be x square e power x. After making coefficient of y2 to be equal to 1, after that you have to take r, right? X square e power x divided by, what is w? W is minus 2 times x power minus 1, x, right? 2 times x power minus 1 will get cancelled. Minus 1 will be plus. Now 1 by 2 e power x dx, but e power x by 2. Now you find g of x. G of x is integration of ur by w dx. Integration of 2 is x, r is e power x divided by w is x power minus 1. Will be minus 1 by 2 integration of, take this 1 by x to numerator, we will have e power x dx, right? Yeah, integration of x square e power x dx. So again, very simple. You can make use of Bernoulli's formula. Minus integration of uv1 minus u dash v2 plus u double dash v3 and so on, right? What is u here? U is x square dv. Take b. dv is e power x dx. 1 is 2x, u2 is 2, u3 is 0. Or you can also apply integration by parts twice. So v1 is e power x, v2 is again e power x, right? So u double dash is 0, uv1, u dash, u double dash is 2, so u triple dash is 0. So we don't need, so we can move. It's enough to find the first 3 terms. Minus 1 by 2 u1 x square e power x u dash v2 plus u double dash power x, e is e power x, integration of e power x is e power x. Right? So we have, if we take e power x outside, e power x outside, square 2x square square g of x, right? So integration of u r by w 1 minus dash v. That's it, right? So therefore your partial integral is x into f of x plus b into g of x, sorry, u into f of x plus b into g of x. U is x, f of x is for x by 2, b is 1 by x, g of x is e power x by 2 square minus 2. This is a partial integral. Both this is equal to c pi. Add it up, you will get the required. Is it clear? We'll move on to the next problem, right? The problem. All the problem. All y2 x y1 plus y equal to y 1 minus. So solution. So we need to solve by method of variation parameters. First step is x square y2 plus 3x y1 plus y is equal to the same as x square d square plus 3x d1 of y is equal to d is d by dx. This d by dx. Now this is a Cauchy-Euler equation. X equal to e power z implies z will be log x. So we have d1 minus 1 plus 3 times d1 1 of y is equal to 0. Thus you have to replace x square d square by d1 minus by d1. Okay, minus d1 plus d1 plus 2d1 plus 1 of y is equal. Therefore the roots here are d plus whole square, right? The roots are 1 and 1. Roots are 1 1, right? Therefore what is your is minus 1 minus 1, right? D plus 1 whole square minus 1 minus. Therefore your CF is 1 plus C is Z, C2 is Z, e power minus Z. This is your characteristic. So C Z is log x, e power minus log x, E1 log x, nothing but x power minus 1, E1 x power minus 1, x power minus log x. So we have u of x to be x power minus 1, u of x to be x power minus 1 log x, of x to be. Now what is r of x? R of x is divided by x square, right? So divide throughout by x square. R of x is 1 by x square to 1 minus x whole square. Right? You shouldn't take r to be this term. So you can take r to be this term if the coefficient of y2 is 1. But here we have x square. Divide throughout by x square. So we have 1 by x square to 1 minus x. What is your Rand scheme? U dash. So u is 1 by x. So its derivative is minus 1 by x square. Is 1 by x log x. Its derivative is apply UV method, product rule. So 1 by x, derivative of log x is 1 by x, plus log x, derivative of 1 by x is minus 1 by x. Expands written. So 1 by x square, right? 1 by x, this is 1 by x cube. 1 by x minus 1 by x log x, right? This x1 determinant, right? 1 by x into 1 by x square is 1 by x cube. And we have minus here. So minus 1 by x square into 1 by x is minus 1 by x cube log. And in between you have minus 1 by x log x into this. Minus minus will be plus here. Yeah, 1 by x log get cancel. X power minus 3 per large scale, right? Now we will find partial integral, nothing but u into f of x plus b of x. What is f of x? Integration of minus v r by w dx minus integration of, so what is v or minus 1 log x divided by, what is w? W is x power minus 3. What is r? R is 1 by x square x whole square, right? 1 whole square. Now we need to simplify, right? We need to simplify. Now integration of, so we have minus, you can see, take this x power minus 2, x power minus 2, right? X power minus 2, x power minus 1 is x power minus 3. So x power minus 3, x power minus 3 will get cancelled. These 3 term will be cancelled, right? Take x power 2 the numerator, x power minus 3. Sorry, if you take this term numerator x power minus 2, x power minus 2, x power minus 3, x power minus 3, this x power minus 3 will get cancelled. Now log x 2 minus x power minus 3 to apply integration by parts. We need to choose u in this order, right? We already explained. U to be log x be 1 minus x whole power minus of b du. U minus b du. That's integration of u is log x. So what is dv, right? Now what is v? Integrate this. So 1 minus x whole power minus 2 plus 1 by 2 plus 1 minus of 1 minus x whole power minus over b, right? Minus of 1 minus x power minus. So u is log x, b is of 1 minus 1 minus integration of, what is b? Is minus integration of 1 minus or minus 1. What is du? Du is 1 by x dx, right? Because derivative log is 1 by x dx. Now this is nothing but minus of log x minus 1 minus whole power minus 1 plus integration of 1 by x 1 minus. So apply partial fraction, right? Right? Partial fraction. So we take this minus inside. So minus log x plus 1 minus whole power minus. Now we need to apply partial fraction, right? So but a by x plus b by 1 minus x. A by x will get a and b to be equal to 1, right? You will get a and b to be equal to 1. We will have this to be equal to integration of to be these two are in products, right? Multiplied, add it up. This is product. These two are products, right? Into v. Minus minus will be plus. We will have log x by 1 minus x, right? Log x by minus x. Is it right? Log we have made some. 2 is log x, 2 is 1 by x. Just a minute. You need different inside, right? You have minus 1. So integrate and you have to inside term, right? Put it up in the denominator. You will have minus 1 b plus 1 minus x whole is plus 1 minus x. Write down, right? Just bringing this minus inside. Minus of this plus this. So now we will have this 2. Now you need to apply partial fraction here. So we will have a by x plus b by 1 minus x. Right? A by x plus b by 1 minus x. Find a and b. You will get a and b to be 1 minus log x plus we will have this term to be integration 1 by x log a and b to be equal to 1. Very simple, right? We are many. We will have minus log x by 1 minus plus log x log of. Here we should have its derivative. Here should have minus 1 here. Hence this missing. Will multiply will be minus log of your f of x. Okay, this is your f of x. Here, very simple, right? You didn't apply integration by parts, that's it. Now we will find g of x. Integration of r by u dx. Integration of u into r. U is 1 by x power minus 1. R is u is 2x power u. W is x power minus r is 1 by square x. Now you can see this power minus 1 power minus x power 2 will get cancelled. So we will have it of 1 power minus but inside we have minus 4. This will get cancelled. Now 1 minus x power minus 1. Therefore, here is f of x u into f of x plus b into g of x. AC. Right? You need to add it up, right? You know b, you know f of x and you g of x back here and add it up to get the solution. Very simple. 13. All y double dash minus x y dash y is equal to x log x. Greater than solve everything with variational parameter. We have put this term to be equal to 0 first. We have x square y double dash y is equal to 0 plus x square minus 2 plus 2 of y is equal to 0, which is the Cauchy-Euler equation equal to e power z x. That is log x. So we have term to be d1 1 plus 2 of y is equal to 0. Get this d1 is d by d. We will have this term to be d1 1 plus 2 of y is equal to 0. So you just find the roots for this. You will have 1 and 2, right? Roots are 1 and 2. F is e1 e power z, 2 e power 2 z. This is log x. Same as 1x 2 x power, right? 2 x power 2. So we will have u of x to be equal to x P of x equal to x square. What is your R of x? It is x log x divided by x square, right? Divided by x square. So we will have log x by x. Log x by. Now what is your Wronskian? Wronskian is u dash e dash. Wronskian of u is x. Derivative is 1. Is a derivative 2x. 2x square minus square is our Wronskian. Therefore, what is our partial integral of x plus b to g of x? We already know u and v. What is f of x? As integration of r divided by of b r. P is x. R is log x by x. W is okay. R is log x by x. So x square, x will get cancelled. So we have integration of x power minus log x, right? We have integration of power minus or we have log x 1 by x. Very simple, right? So you put u to be log x. Put u to be log x. So your du 1 by x. So du. U is log x minus u square by 2 plus u is log x minus log x whole square 2 is our f of x. Now you find g of x. Integration of ur by x. Integration of u r. U is x. R is log x by x. W is x square. So we will have integration of x power minus 2 log x. Power minus 2 log x. You need to apply Bernoulli's from our integration by parts. So ILAT. So have I to ILA ILAT. You need to choose U order, right? That means U to be take U to be log x V1 V2 plus U double dash V. Take U log x or minus 2 dx. Your u1 is 1 by x. 1 is x. This will go on and on. We will apply. First, we will see what happened. To be minus integration of v du, right? So u is log x is integration of this or minus 2 plus 1. 2 plus 1. Integration of v du. Du. So by x x. Right? So we'll write integration by parts. For u dv, right? Or minus 2. Yeah, d. Integration of dv of v is 1 by x dx. So this will log x or minus 1 by minus 1. And what about this term? Oh, yes. Now we can see this term will get cancelled, right? X power minus 1. Here we have p plus integration of will be x power minus 1 x power minus 2 dx, right? Okay, minus this will be minus 1. Take this term will be plus 1. variation of this will be x power minus power minus 1 x power minus x power minus 1 log x plus power minus power minus x minus power minus this your g of x, g of x. That's it. So therefore, that PA is u into f of x, g of x. General solution is equal to f plus. You need to add it up, and not writing. You know f of x, g of x. Substitute all these terms. Get the required answer. So last problem, another topic. All these are very, very easy problems. All right, of variation where 2d of y equal to e power x tan x. So I'll do this fast. So last problem. First we need to put equal to 0. So is equal to 0. So we have, if I solve this, you will have d to be half divided by 2 times, so 2 plus or minus 4 minus 8, 4, 2y, 1 plus or minus I. Our characteristic of this power z 1 cos z plus c z, right? From alpha plus or minus I. E power alpha is z, but cos beta is z plus sin beta is z. You have to replace it by log x power log x cos of x into of log x. So T1 x cos of log x, x sin of log x. Right? So this will be x, multiply these two terms. Your u of x is e power z. Sorry, we don't have z, right? Because it is second order, the constant quotient one. Right? Sorry. It is Cauchy Euler only is equal to e power z. In that case, for independent variable is z. So e power x cos beta x. Therefore, your u of x is e power x cos x, and v of x is e power x, and your r is e power x tan x. What is your Ranskin? E of x e power x cos x. Its derivative. Formula 2 dash dash. So e power x cos x. Differentiate this, e power x, derivative of cos x is plus cos x power x. Applying product rule. Here we have e power x sin power x cos x. Derivative of e power x is e power x. Cross multiply this, you will have e power x cos x, e power x cos x, e power x cos x. So simplify this, what you will have is this, we will have e power x cos x, power x cos x, power x e power x sin x, right? Power x cos x, power x cos x to e minus this term plus here power x power x this in this term power x e power x of x get cancelled. So if I take e power 2 common, here we have cos square x plus sin square x e power 2x cancel. So what is your pi? 2 into f of x plus b into g of x. What is f of x of star x minus integration of b power x sin x by w is e power 2x r is e power x tan x. Power x e power x e power 2x get cancelled of sin x tan x dx. This we already did earlier itself. We have integration of tan x is sin by cos. So we have sin x by cos x. All of integral, right? Sin square x is 1 by cos square x dx. Cos x minus integration of 1 by cos x dx and plus integration of cos x. It just divide cos x separately. Minus 1 by cos x minus will be plus cos will get cancelled. So we have this term. Minus what is integration of x? Log secant x tan x, right? Log secant x tan x. Integration of cos x is sin x. This is your of x. Now you find g of x. Integration of r by w dx. Integration of u. So what is u? Power x cos x. W is power 2x. R is power x tan x. Power x e power cancel. Have integration of cos x tan x is x by cos x. Integration of cos x. Therefore, the PA is u into of x plus b of x. What is u? Is e power x cos x into f of x. F of x is sin x minus log of secant x tan x plus b g of x. So this power x sin x to g of x cos x. Particular integral for general solution equal to add it up. Very easy problem. Very one is very easy problem. To practice similar problem from the textbook, everything will be very. Do you want me to solve some more problems, or I will stop here? Do I need to solve some more problems, or I will stop and use some exercise problem, right? Okay, I think we have solved 14 problems. That is enough. Practice more problems from method of variation. Yes. Only thing is you need to integrate. That's it. You know how to integrate. You can easily do the problems. I'll give you some exercise from group. Very easy. Right? This class, solve. Yes, okay. So I'll use some exercise problems also. Right? If you want, I can also paste it here. I'll give you some exercise problem. I'll give you some exercise problem. solve this problem, right? These are 15 problem. This is a 15th problem. Very easy, right? You just have to integrate, that's it. For 16th problem, solve by method of variation of this. And 17th 17th problem, we have 4 subdivisions: 1, 2, 3, and 4. Solution for 1. Solution for 1. This solution for 2. This solution for 3. Fourth problem, very simple. Do from third problem, right? Do as the third subject. So we have so we have did 17 problems, right? So I think we can do any problem asked. That's it, right? If you can ask, I'll find out. Next class we'll be starting next topic. We have 3 more topics left. One is orthogonal trajectories, and the second is solving higher degree equations, and third is Laplace transform to solve a differential equation. Laplace transform method solve a differential equation. We'll finish these topics very quickly. After that, we'll analytical. Maximum another 5 to 6 classes. We will take analytical geometry after this. Okay, thank you. Thank you.